Okay, so we're going to look at some compound angle formulas. Last time we looked at the trigonometric identities, and we're going to have a look at these compound angle formulas, and then there's some really good questions on these actually that you'll be able to work through. But the first one we're going to have a look at is the compound angle formula sine A plus B. Okay. Now, it's really important to realize, I'll try and go slow through this because I know that there can be quite a lot of delay. Sine A plus B is not equal to sine A plus sine B, okay? That is not true. Can you see what I've written? Okay. Yeah, absolutely. And even if you consider certain numbers, let's do sine 30 plus 60. So that's sine of what? Sine of 90. And sine of 90 is 1. And if I was considering it like this, that would be sine of 30 plus sine of 60. Sine of 30 using is pi over 6. Sorry, that's radians. Sine of 30 is, if I think of my triangle, 60, 30, 1, 2, root 3, so that's a half. Plus sine of 60 is root 3 over 2. And these two things added together do not give me 1, okay? So this is not true, okay? Please do not make that mistake. Is that okay? Now, the good thing is, you're given the formula that I'm about to write down, you're given it in your formula booklet. So you don't need to remember it. However, you'll probably use it so much that it will become ingrained in your brain from now on. But the formula is sine A plus B is equal to sine A cos B plus cos A sine B. Okay, and that is given to you in your formula booklet. Now we're going to prove that using these two triangles. So I've got two right angle triangles. I've got OQR, and OQR has got the angle A, and then we've got the other triangle OPQ, and this has got the angle B. Is that okay? Everybody can see that? Yeah? Okay. So what we can, so this is our proof. So what I'm going to do is I'm going to draw some construction lines on this diagram. So these lines are going to help us prove this result, okay, this equation. So the first one I'm going to do is I'm going to draw a straight line down, which is going to meet at 90 degrees. Okay. The next one I'm going to draw is the next construction line is just going to go directly straight line, please, straight through and make another right angle triangle. Okay, so I've just drawn in a couple of construction lines to help me prove this result. And I'm going to label them. S, T, and U. Okay, so let me know when you can see the construction lines and the labeled points. Okay. So, with this information that we've got here, now let's see if I can figure this out. I'm gonna scribble a few things in here. I recommend if you're copying this down or making notes, copy this by all means, but don't put in whatever I have in green, okay? Because I'm going to erase it. What can you tell me that this angle is here that I've just drawn in green? Hopefully you'll see it in a second. No, no. I know that this is, this one is 90. B. So this is? Okay, can you simplify that for me? Mm-hmm. Mm-hmm. Yeah, 90 minus B. This is 90 minus B because these two have to add up to 90 and add on another 90. That gives me 180. So then what is this angle here at U? What is this one? Don't write the stuff in green. Okay, which is? No, 180 minus 90 minus B. So that's 180 minus 90 plus B. That gives me B. Okay, so this angle in here is B. Is that okay? Okay. Now, yeah, that makes sense, doesn't it? I'm just querying my own work. Yeah, of course it does. Right. Well, what does this one then equal? Here. Yep, 90 minus B, and we can think of that because opposite angles are equal. This angle is going to be 90. That means that this one is going to be B. And that means that, and if this is a, so looking at the triangle RUQ, can you see RUQ? Okay, that is a right angle triangle, correct? And if the angle at Q is 90, the angle at U is 90 minus B, that means that this one must be B. Okay. All right, so does that make sense so far? Marco? Okay, so what I'm going to do is, I don't need all of these angles. I only need a couple of them. So I'm going to keep, okay, I'm going to keep this one, B. Oh, no, that's not going to work. And so I'm going to get rid of all the stuff in green. And I'm going to put in just the stuff that I want, which is this one and this one. Okay. So I've just put in those two angles that are B in red. All right. Good. So here goes with the proof. Okay. So I've got sine of A plus B. So sine of any angle is always equal to what over what? Oh, opposite over hypotenuse. Okay. So looking at our triangle ORT, okay, I can see there's A plus B. What is sine of A plus B then if it's opposite over hypotenuse in terms of the letters there? Yep, over, yeah, dr over RO. Is that okay, Jaden? Opposite over hypotenuse. You sure, Jaden? You're not convincing me that you're okay. Okay. Yeah, it doesn't matter which way around you put it, that's correct. So opposite over hypotenuse. Okay. Now, TR is the same as what? TR is the same as RS plus what? RS plus, yeah, SU plus UT. Or I could just say plus QP. And I'm going to say plus QP because that is going to help me out in just a second. Is that okay? That's still all over RO. And I can just use my rules of fractions here. It's over the same common denominator. Okay, so just put them as separate fractions. And then this is where it gets interesting. Now, I know, okay, so this is what I'm trying to prove, okay? What is sine A equal to? So here is A. Looking at a triangle involved here, what is sine of A equal to? RQ over RO, right, good, yes. Do you say that, Jaden? I've got my right angle triangle. So sine of A is RQ over RO. So what I'm going to do is, yep. RT. So just for sine A, so here is A. Yep. Yep. I'm only interested in A at the minute, just because I'm thinking about what does sine A equal? Sine A equals, yep, opposite over hypotenuse. So RQ over RO. So what I'm going to do is I'm going to multiply this fraction by RQ. Now, obviously, I don't want to change this fraction, so what do I have to do to cancel this out? Divide, right. And if I look at this carefully, what does RS over RQ equal? So RS over RQ. Nope. Cos of B, right, okay, because this would be the adjacent, this is the hypotenuse. Okay, we'll come to that in a second. We'll come back to that in a second. So looking at my other fraction, QP over RO, I'm going to think of it the same way. Okay, what does cos of A equal? So here's A again. Jaden, can you tell me what cos of A equals? Mm-hmm. Yep, over, yep, OQ adjacent over hypotenuse. So OQ over RO. So what I'm going to do is I'm going to do the same thing. I'm going to multiply this fraction by OQ, but obviously I don't want to change it, so I'm going to divide by it as well and get down to here. Once we've done that, we are pretty much good because if I've got RS over RQ, we've already said, well, RS, let me just draw a little triangle. So I'm just redrawing this triangle, RS, and Q. This is B. There's the angle. This would be the opposite, adjacent hypotenuse. So RS over RQ, that's adjacent over hypotenuse. So this is cos of b. Yep. Just leave it for a second. And then RQ over RO. RQ over RO. Okay, well that's just sine of A. And then we're going to add on QP over QO. What is QP over QO? Let's draw this triangle just to hopefully make it a bit more clear. Yep, sine of what? Yes, good. So there's the triangle. I've just taken this triangle and redrawn it. So this is my opposite, adjacent, hypotenuse. So QP over OQ is sine of B. And then OQ over RO. Sorry, where's OQ? Over RO. Yes. So looking at the big triangle again, this one. What is OQ over RO? Of A. Yeah, good, because there's the angle. This would be adjacent. Yep, adjacent over hypotenuse. So this would be cos of A. And so there we have proven our first compound angle formula. How did we find that? It's not. And the thing is, in the exam, they wouldn't just say prove that sine A plus B equals this. Okay, they would more than likely have a diagram like this and then guide you through it. Okay, but it will obviously be easier if you have seen this. Okay, it'll help with kind of the understanding. Now there are others. So this is the first one. And like I said, it's given to you in your formula booklet. Let me write down another one. So sine of A minus B is equal to, yeah, so cos B sine A. It would be subtract. And so that's the second one. Now, the questions that I want you to have a look at, because these are good questions and they kind of, they are on page 404. And the first question in there gets you to prove this one, okay? And it's very, very similar, okay? It's just replacing B with negative B. I wouldn't really bother with that one because it's just imagining the angle going in the opposite direction. The one that is quite a good question is question 2, which is this compound angle formula. So you have to prove this one doing it a very similar way. Cos A, cos B, and it's minus sine A, sine B. Okay, so question 2 is proving this one. And you do it using the same triangle. And this is intentional. This is plus here, and this is minus, okay? So what I would like you to have a go at is question 2A. Don't worry about B. And then question 3A is a really good one. Don't worry about B. And then question 4 onwards are really good questions for sure. Okay. I know there's only 8 minutes left, but I would definitely encourage you to make a start on that now. And if you've got any questions, just let me know, okay? Um, like I said, the proof of this cos of a plus b, you're gonna, as far as I remember off the top of my head, you use the same diagram and set it up the same way, okay? All good?